My name is Dr. Mike Murphy. I'm an assistant professor of computer science and information systems at Coastal Carolina University.
In this lecture, I'm going to introduce file organization and discuss paths within a file system. We store files on a computer using something called a tree hierarchy. A tree hierarchy is a way of organizing our data so that we're able to find it later whenever we need to access it. A tree hierarchy consists of a data structure which we call a tree, which is loosely based on the type of tree that you would find growing outdoors, except that we typically draw it upside down. The point at which this tree begins is called the root. Underneath the root, we have various branches of the tree, and these branches can have further branches. When a branch does not have any further branches, we call that type of branch a leaf. Now, in a file system for organizing our files, the root directory of the file system goes at the root of the tree. Any branches that have other branches are called subdirectories, and the files, or the individual units of data that we're actually trying to access, live either in the root directory or in one of its subdirectories. If I take this simple tree and label it, I can call my topmost, or my root directory, top. I'll call my subdirectories A, B, and C, and I'll simply number my files going from left to right. 1, 2, 3, 4, 5, 6. There's nothing special about these labels. This is just to give us a convenient point from which to work in the rest of the lecture. Now, a path in a file system is simply a set of instructions that tells us how to get to a particular file that's stored somewhere on disk. For example, if I want to get to file number 3 in this example, I know I need to start at the top, because this is the entry point into my file system, go to subdirectory A, then go to subdirectory C, and from subdirectory C, I can access file number 3. So I can write some simple directions to get to file number 3 by saying that I want to start at the top, go to A, go to C, and then access file number 3. It's more convenient to abbreviate these types of instructions to make them shorter to write and easier to process on a computer. Here I have an example of a path in a computer file system. The leading slash on this path tells me to start at the top. Then, this path tells me to go to A, then to go to C, and then to access file number 3, which is in the subdirectory C, which is a subdirectory of A, which is a subdirectory of the root directory. Each of these forward slashes in this example is called a path separator, and each of the items in between, or after the slash, is called a path component. On the web and on Unix-like systems, including Linux, we use a forward slash as our path separator. So we can label each of these files in our sample file system using forward slashes that tell us how to get from the top directory, which we represent with a single slash, to the file. So for example, this path here, /A/C/1, means start at the top directory, represented by a single slash, go to A, then go to C, and then access file number 1 within C. File number 6 lives directly in the top directory, and so we simply say /6, meaning start at the top directory and then access file number 6 directly. On a Windows system, we would use a backslash as a path separator. Furthermore, paths in Windows, or absolute paths in Windows, which I'll talk more about in a moment, begin with a drive letter and a colon. In this case, I'm using the letter L to represent the drive letter, but this can change depending on how the drives are attached to the system. So, for example here, file number 3 has a path L:\A/C/3. This means to start at the top, which has the path of L:\, then go to A, then go to C, and finally go to 3. Absolute paths on any file system start at the top. Absolute paths are a way of giving us directions to get to a specific file starting from the very top of the file system. So, if I have the absolute path /A/C/3 on a Unix system or on a web page, or on a Windows system if I have L:\A/C/3, these are ways of telling me to start at the top of my file system, go to A, then go to C, and then access file number 3. Relative paths, on the other hand, start from some location in the tree. And it's important to note that in order for a relative path to have any meaning whatsoever, we have to know the point at which we're starting. Here I've labeled our starting point with a friendly message that says you are here. I then have a relative path that on a Unix or web system looks like C/3, or on Windows, C/3. And what this says is, from our current starting point, which is A, go to C, and then access file number 3 at C. Sometimes we might want to go up in a file system using a relative path. We can go up using a special path component ... or two dots side by side. This is a special way of saying go up one level in our tree. So if I'm starting at B, once again I need a starting point in order for a relative path to make any sense whatsoever. I'm starting at B. I have the path ... /A/C/3, or using backslashes if I'm in Windows. This means first I want to go up. That'll take me to my top level directory. Then I want to go to A. Then I want to go to C. And then I can access file number 3. One other special symbol that I can use in a path is a single dot. And a single dot refers to the current directory. It means go nowhere, or stay put. So if I start in directory A, and I see a single dot, I simply stay in directory A. Now let's practice using these techniques to find a relative path starting from directory C in order to access file number 5. Well, starting from directory C, I can see that to get to file number 5, the very first step I need to take in this path is to go up one directory. I can only move one of these tree links, one of these branches, at a time. So I need to go up from C to A. And to do that, I simply use the special symbol for going up, which is two dots next to each other, or ... From A, I need to go to my top level directory. Once again, I use another ... Notice that I put a path separator between the two ... that I have. So in Unix or in the web, I use a /, and in Windows, I use a backslash here. So my current path so far in Unix or web notation is ... Now I can see that in order to get to 5, I'm going to need to go into B first. So I simply add B to my path. So from C, I'm going to go up one level to A. That's these first two dots. I'm going to go up one more level to the top level directory. That's the second two dots. And then I'm going to go down to B, simply using B here. Now from B, I can access 5 directly. So I simply put a path separator followed by the name. So once again, to get from C to being able to access file number 5, I need to go up, which is ... Need to go up again, another ... Go down with B, and then access the file directly by its name, in this case 5. We can also work the other way. If we're given a starting location and given a relative path, we can follow that relative path to its destination. We can give the final destination as a relative path to another directory, or in this example, we'll give it as an absolute path, a path relative to the top of the file system. So if we begin here at B and we have a relative path ... /A/C/2, we're going to begin by following the first path component. We're only going to look at this first component for now. So it says ... that means go up one level. That will put us at the top level directory. Then we see in the next path component after the separator the letter A. That means that we want to go from the top level directory, or the root directory where we just were, to A. We then look at the next path component. In this case, it tells us to go to C. And finally, the last component of the path gives us a destination in the file system, which is file number 2. So if we look at our tree here, we can see that the way that we would get from this directory, from the root of the tree, to this file, number 2, is via the absolute path /A/C/2. And in Windows, we would use a drive letter and backslashes instead of the forward slashes. Now, relative paths can be absolutely crazy, lengthy, and somewhat complex to follow. Here's an example. I know I'm starting in directory C, and I'm given this really long relative path. ... /A/C/C/2. Now, at first, this may seem a bit daunting, and a fairly long path to trace. But as long as we break this down into its components by dividing this path at the path separators, this process is actually fairly straightforward. Let's begin by addressing the first path component, the first ... before the first path separator. This component is telling us to go up. So we are going from C to A. Our next two path separators, I just realized a slide is missing. Our next two path separators, I should say, tell us to go up one. That's this ... right here, and then stay put at the top level directory once we get there. That's what the single dot means. So step 1 got us from C to A. Step 2, this second ... here, takes us from A to the top level directory. And then step 3, the single dot, tells us to stay put in the top level directory. Step 4 tells us to go back to A. Step 5 tells us to go back to C. Step 6 tells us to go up again. This is going to send us back to A. Step 7 is going to take us back to C. And finally, we're going to access file number 2, which was in subdirectory C. We can write the absolute path to this final destination where we ended up by writing /A/C/2. That would be the set of instructions to get us from the root directory to that file. Now notice, since I started here in subdirectory C and file number 2 was stored in subdirectory C, I could have just given the simplest relative path from this starting location to this file, and that simply would have been the number 2 by itself, with no slashes or anything. So relative paths can be fairly complex, and the system will process these paths and turn them into meaningful paths to the system in order to be able to find your files.